Venus is the second planet from the Sun, orbiting it every 224.7 Earth days. It has the longest rotation period, 245 days, of any planet in the solar system, and, unusually, rotates in the opposite direction to most other planets. It has no natural satellite. It is named after the Roman goddess of love and beauty. After the Moon, it is the brightest natural object in the night sky, reaching an apparent magnitude of -4.6, bright enough to cast shadows. Because Venus is an inferior planet from Earth, it never appears to venture far from the Sun. Its elongation reaches a maximum of 47.8 degrees. Venus is a terrestrial planet and is sometimes called Earth's sister planet because of their similar size, mass, proximity to the Sun and bulk composition. It is radically different from Earth in other respects. It has the densest atmosphere of the four terrestrial planets, consisting of more than 96% carbon dioxide. The atmospheric pressure at the planet's surface is 92 times that of Earth. With a mean surface temperature of 735 K, 462 degrees Celsius, 863 degrees Fahrenheit, Venus is by far the hottest planet in the solar system. Even though Mercury is closer to the Sun, Venus is shrouded by an opaque layer of highly reflective clouds of sulfuric acid, preventing its surface from being seen from space in visible light. It may have had oceans in the past, but these would have vaporized as the temperature rose due to a runaway greenhouse effect. The water has most probably photodissociated, and, because of the lack of a planetary magnetic field, the free hydrogen has been swept into interplanetary space by the solar wind. Venus's surface is a dry desertscape interspersed with slab-like rocks and periodically resurfaced by volcanism. As one of the brightest objects in the sky, Venus has been a major fixture in human culture for as long as records have existed. It has been made sacred to gods of many cultures, and, as the morning star and evening star, has been a prime inspiration for writers and poets. Venus was the first planet to have its motions across the sky plotted, as early as the second millennium BC, and, as the closest planet to Earth, was a prime target for early interplanetary exploration. It was the first planet beyond Earth visited by a spacecraft, Mariner 2. In 1962, and the first to be successfully landed on, by Venera 7, in 1970. Venus's thick clouds render observation of its surface impossible in visible light, and the first detailed maps did not emerge until the arrival of the Magellan orbiter in 1991. Plans have been proposed for rovers or more complex missions, but they are hindered by Venus's hostile surface conditions. Physical characteristics: Venus is one of the four terrestrial planets in the solar system, meaning that, like Earth, it is a rocky body. In size and mass, it is similar to Earth, and is often described as Earth's sister or twin. The diameter of Venus is 12,092 kilometers, only 650 kilometers less than Earth's, and its mass is 81.5% of Earth's. Conditions on the Venusian surface differ radically from those on Earth because of its dense carbon dioxide atmosphere. The mass of the atmosphere of Venus is 96.5% carbon dioxide, with most of the remaining 3.5% being nitrogen. Geography: the Venusian surface was a subject of speculation until some of its secrets were revealed by planetary science in the 20th century. Venerlanders in 1975 and 1982 returned images of a surface covered in sediment and relatively angular rocks. The surface was mapped in detail by Magellan in 1990 to 91. The ground shows evidence of extensive volcanism, and the sulfur in the atmosphere may indicate there have been some recent eruptions. About 80% of the Venusian surface is covered by smooth, volcanic plains, consisting of 70% plains with wrinkle ridges and 10% smooth or lobate plains. Two highland continents make up the rest of its surface area, one lying in the planet's northern hemisphere and the other just south of the equator. The northern continent is called Ishtar Terra, after Ishtar, the Babylonian goddess of love, and is about the size of Australia. Maxwell Montes, the highest mountain on Venus, lies on Ishtar Terra. Its peak is 11 kilometers above the Venusian average surface elevation. The southern continent is called Aphrodite Terra, after the Greek goddess of love, and is the larger of the two highland regions, roughly the size of South America. A network of fractures and faults covers much of this area. The absence of evidence of lava flow accompanying any of the visible caldera remains an enigma. The planet has few impact craters, demonstrating the surface is relatively young, approximately 300 to 600 million years old. In addition to the impact craters, mountains, and valleys commonly found on rocky planets, Venus has some unique surface features. Among these are flat-topped volcanic features called pharos, which look somewhat like pancakes and range in size from 20 to 50 kilometers across, and from 100 to 1,000 meters high. Radial, star-like fracture systems called novae, features with both radial and concentric fractures resembling spider webs, known as arachnoids, and coronae, circular rings of fractures sometimes surrounded by a depression. These features are volcanic in origin. Most Venusian surface features are named after historical and mythological women. Exceptions are Maxwell Montes, named after James Clerk Maxwell, and highland regions Alpha Regio, Beta Regio and Octa Regio. The latter three features were named before the current system was adopted by the International Astronomical Union, the body that oversees planetary nomenclature. The longitudes of physical features on Venus are expressed relative to its prime meridian. The original prime meridian passed through the radar bright spot at the center of the oval feature Eve, located south of Alpha Regio. After the Venera missions were completed, the prime meridian was redefined to pass through the central peak in the crater Ariadne. Surface geology. Much of the Venusian surface appears to have been shaped by volcanic activity. Venus has several times as many volcanoes as Earth, and it has 167 large volcanoes that are over 100 kilometers across. The only volcanic complex of this size on Earth is the Big Island of Hawaii. This is not because Venus is more volcanically active than Earth, but because its crust is older. Earth's oceanic crust is continually recycled by subduction at the boundaries of tectonic plates, and has an average age of about 100 million years, whereas the Venusian surface is estimated to be 300 to 600 million years old. Several lines of evidence point to ongoing volcanic activity on Venus. During the Soviet Venera program, the Venera 9 orbiter obtained spectroscopic evidence of lightning on Venus, and the Venera 12 descent probe obtained additional evidence of lightning and thunder. The European Space Agency's Venus Express in 2007 detected Whistler waves, further confirming the occurrence of lightning on Venus. Although rainfall drives thunderstorms on Earth, there is no rainfall on the surface of Venus, though sulfuric acid rain falls in the upper atmosphere, then evaporates around 25 kilometers above the surface. One possibility is that ash from a volcanic eruption was generating the lightning. Another piece of evidence comes from measurements of sulfur dioxide concentrations in the atmosphere, which dropped by a factor of 10 between 1978 and 1986, jumped in 2006, and again declined tenfold. This may mean that levels had been boosted several times by large volcanic eruptions. In 2008 and 2009, the first direct evidence for ongoing volcanism was observed by Venus Express, in the form of 4 transient localized infrared hotspots within the rift zone Ganeshchisma, near the shield volcano Moutmans. 3 of the spots were observed in more than one successive orbit. These spots are thought to represent lava freshly released by volcanic eruptions. The actual temperatures are not known, because the size of the hotspots could not be measured, but are likely have been in the 800 to 1100 K range, relative to a normal temperature of 740 K. Almost 1,000 impact craters on Venus are evenly distributed across its surface. On other cratered bodies, such as Earth and the Moon, craters show a range of states of degradation. On the Moon, degradation is caused by subsequent impacts, whereas on Earth it is caused by wind and rain erosion. On Venus, about 85% of the craters are in pristine condition. The number of craters, together with their well-preserved condition, indicates the planet underwent a global resurfacing event about 300 to 600 million years ago, followed by a decay in volcanism. Whereas Earth's crust is in continuous motion, Venus is thought to be unable to sustain such a process. Without plate tectonics to dissipate heat from its mantle, Venus instead undergoes a cyclical process in which mantle temperatures rise until they reach a critical level that weakens the crust. Then, over a period of about 100 million years, subduction occurs on an enormous scale, completely recycling the crust. Venusian craters range from 3 km to 280 km in diameter. No craters are smaller than 3 km, because of the effects of the dense atmosphere on incoming objects. Objects with less than a certain kinetic energy are slowed down so much by the atmosphere that they do not create an impact crater. Incoming projectiles less than 50 meters in diameter will fragment and burn up in the atmosphere before reaching the ground. Internal structure: without seismic data or knowledge of its moment of inertia, little direct information is available about the internal structure and geochemistry of Venus. The similarity in size and density between Venus and Earth suggests they share a similar internal structure, a core, mantle, and crust. Like that of Earth, the Venusian core is at least partially liquid because the two planets have been cooling at about the same rate. The slightly smaller size of Venus means pressures are 24% lower in its deep interior than Earth's. The principal difference between the two planets is the lack of evidence for plate tectonics on Venus, possibly because its crust is too strong to subduct without water to make it less viscous. This results in reduced heat loss from the planet, preventing it from cooling and providing a likely explanation for its lack of an internally generated magnetic field. Instead, Venus may lose its internal heat in periodic major resurfacing events. Atmosphere and climate: Venus has an extremely dense atmosphere composed of 96.5% carbon dioxide, 3.5% nitrogen, and traces of other gases, most notably sulfur dioxide. The mass of its atmosphere is 93 times that of Earth's, whereas the pressure at its surface is about 92 times that at Earth's, a pressure equivalent to that at a depth of nearly 1 kilometer under Earth's oceans. The density at the surface is 65 kg/m3, 6.5% that of water, or 50 times as dense as Earth's atmosphere at 20 degrees Celsius at sea level. The CO2-rich atmosphere generates the strongest greenhouse effect in the solar system, creating surface temperatures of at least 735 K, 462 degrees Celsius. This makes Venus's surface hotter than Mercury's, which has a minimum surface temperature of 55 K, minus 220 degrees Celsius, and maximum surface temperature of 695 K, 420 degrees Celsius, even though Venus is nearly twice Mercury's distance from the Sun and thus receives only 25% of Mercury's solar irradiance. This temperature is higher than that used for sterilization. The surface of Venus is often said to resemble traditional accounts of hell. Studies have suggested that billions of years ago Venus's atmosphere was much more like Earth's than it is now, and that there may have been substantial quantities of liquid water on the surface, but after a period of 600 million to several billion years, a runaway greenhouse effect was caused by the evaporation of that original water, which generated a critical level of greenhouse gases in its atmosphere. Although the surface conditions on Venus are no longer hospitable to any Earth-like life that may have formed before this event, there is speculation on the possibility that life exists in the upper cloud layers of Venus, 50 kilometers, 31 miles, up from the surface, where the temperature range is between 30 and 80 degrees Celsius, but the environment is acidic. Thermal inertia and the transfer of heat by winds in the lower atmosphere mean that the temperature of Venus's surface does not vary significantly between the night and day sides, despite Venus's extremely slow rotation. Winds at the surface are slow, moving at a few kilometers per hour, but because of the high density of the atmosphere at the surface, they exert a significant amount of force against obstructions, and transport dust and small stones across the surface. This alone would make it difficult for a human to walk through, even if the heat, pressure, and lack of oxygen were not a problem. Above the dense CO2 layer are thick clouds consisting mainly of sulfur dioxide and sulfuric acid droplets. These clouds reflect and scatter about 90% of the sunlight that falls on them back into space, and prevent visual observation of Venus's surface. The permanent cloud cover means that although Venus is closer than Earth to the Sun, it receives less sunlight on the ground. Strong 85 meters per second, 300 kilometers per hour, winds at the cloud tops go around Venus about every 4 to 5 Earth days. Winds on Venus move at up to 60 times the speed of its rotation, whereas Earth's fastest winds are only 10 to 20% rotation speed. The surface of Venus is effectively isothermal. It retains a constant temperature not only between day and night but between the equator and the poles. Venus's metaxial tilt, less than 3 degrees, compared to 23 degrees on Earth, also minimizes seasonal temperature variation. The only appreciable variation in temperature occurs with altitude. The highest point on Venus, Maxwell Montes, is therefore the coolest point on Venus, with a temperature of about 655 K, 380 degrees Celsius, and an atmospheric pressure of about 4.5 megapascals, 45 bar. In 1995, the Magellan spacecraft imaged a highly reflective substance at the tops of the highest mountain peaks that bore a strong resemblance to terrestrial snow. This substance likely formed from a similar process to snow, albeit at a far higher temperature. Too volatile to condense on the surface, it rose in gaseous form to higher elevations, where it is cooler and could precipitate. The identity of this substance is not known with certainty, but speculation has ranged from elemental tellurium to lead sulfide, galena. The clouds of Venus are capable of producing lightning much like the clouds on Earth. The existence of lightning had been controversial since the first suspected bursts were detected by the Soviet Venera probes. In 2006 to 2007, Venus Express clearly detected Whistler mode waves, the signatures of lightning. Their intermittent appearance indicates a pattern associated with weather activity. The lightning rate is at least half of that on Earth. In 2007, Venus Express discovered that a huge double atmospheric vortex exists at the South Pole. Another discovery made by Venus Express in 2011 is that an ozone layer exists high in the atmosphere of Venus. On January 29, 2013, ESA scientists reported that the ionosphere of Venus streams outwards in a manner similar to the ion tail seen streaming from a comet under similar conditions.